Good morning, good afternoon, or good evening, depending on where you're connecting from. I'm really glad to have another chance to be with all of you and with Robert, my co-host. Hi, Robert.
Hey, cheers.
Cheers.
Hey,
So today
we've got right one day.
Yeah. Well, we're getting better.
Yeah.
Today we've got a special show with special guests, and it's called Developing Drones with Open Source. And we're lucky to have with us the community manager of PX4 with us today, and one of the PX4 community specialists. And it's going to be amazing. We're going to have a lot of content today. And I'm really looking forward to the show. But before we do that and we get started with the show, Robert, you mind giving a bit of a recap of what we had last week?
Absolutely. Thank you, Alessandro. So last week was another fun episode of Innovation Coffee where we met with George Moore, who is the principal program manager for Azure Edge devices. It was really fun, actually. George joined us, and in fact, it was interesting to see his setup too. He had a kind of a nice professional streaming setup from the Microsoft office, and he talked to us all about the cool new stuff they're doing around Project Santa Cruz. They showed us a demo where they did people detection in a bunch of different scenarios, in a convenience store, in a cafeteria. And I don't want to necessarily spoil it all, so I would love to just say, hey, go check it out, right? I mean, the episode is still available. You can watch the recording, go get to know George, go get to know Microsoft Azure, and explore the cool new things that they are doing over there. And of course, check the description of the video, because every time we post one of these or do one of these live streams, in the description, we provide all of the links that we share throughout the video. There's lots of opportunities there to participate in various programs and such. So yeah, thanks, Alessandro. There's the recap for last week's episode with George Moore from Microsoft.
Awesome. And I think it's about time we get started on today's episode because there's a lot of exciting stuff to talk about. So let's bring in our guest for today. So Jinger, welcome to the show. And we also got Gonzalo with us. Hi, everyone.
Hello, welcome.
Hi.
Jinger, you want to start?
Yeah, we have a little delay.
Okay. We're really lucky to have Jinger directly tuning in from China today. So thank you, Jinger. I know it's really late on your side, so thank you for joining us. And Gonzalo tuning in from I'm not sure where actually. I think US. Are you in
Portugal.
US? Portugal. Oh, you are in Portugal. Okay, awesome.
Yeah.
So it's actually quite late for you as well. But thank you guys for joining us. And I've actually made a mistake on the introduction earlier. So it's so we got Jinger is community manager at Dronecode Foundation, and Gonzalo is actually PX4 Ambassador. I said something else earlier. So thank you guys for joining us. And I mean, Gonzalo, you're also a software developer, right? Like in general,
Yeah.
And then PX4 Ambassador, yeah. So it's really good to have you guys on the show. And should we start with a short introduction? So Jinger, do you want to go first and tell us a bit about yourself and how we met? Actually, I think that might be an interesting story. But yeah, start with yourself, I guess.
Hi, my name is Jinger, and I'm the community manager at the Dronecode Foundation. I've been working in the drone industry. I think since I think right after college. So it's been a pretty. Today I'll be like mostly sharing like the amazing open source community that we're in. And I have mainly worked with products and community building, being in the ARM Innovator Program since like 2017, and a lot of like hardware and software experience. And really glad to join the show today.
And what's interesting is that me and you, Jinger, met about 4 years ago now. It's been 3 years, maybe. I don't know. It's been quite a long time. So Jinger, as she said, she's one of our ARM innovators, and we've done a lot of really interesting different conferences actually, quite a few actually. I can't remember how many, but so we met. I think first time was in what was it, Taiwan maybe. The first time we met back in 3 years ago, we did a road show actually in Taiwan and China and Japan actually. So Jinger was actually the Arm Innovator with us during the whole road show. So that was awesome.
I still have a bone to pick with Jinger because you were at the AIoT Dev Summit back in December. You took a picture with, I think, Rex, with Alex Glow, with Alessandro, with Jessica from Hackster, but not me. You didn't take a picture with me. So, I mean, maybe next time.
Well, now we can take a screenshot. We can take a screenshot right now, and then we'll have a picture.
Yeah. We'll do one at the end. How about that? That's a good idea.
Yeah.
Cool. I want to give a little, just a chance to also introduce Gonzalo. So if you want to just say a few words about yourself and how you got to work on drones.
I'm an electrotechnical engineer. I'm also military. I started working at the Army in 2017 as a full stack developer. I worked mainly with websites, but before that, on my thesis, I worked with embedded stuff like networking and nodes and stuff like that. And then in 2018, I had a friend of mine that worked with PX4 and introduced me to Jinger, and I started working at some stuff and getting into the drone things, and I just developed the love for it. Yeah.
We talked about this community, right? This drone community, and I wanted to give Jinger a chance to like describe what this drone community is. So I've got the T-shirt from last year actually developer event that you guys run. So it was a really fun event, actually, really greatly run. And Jinger, could you tell us a bit more about PX4 and Dronecode?
Yeah, absolutely. And I think part of what I will do is actually kind of how I thought into this community, right? From my personal journey side of things. So like I said, when I was in college, I was in mechanical engineering, and at the time it was in University of Nevada, Las Vegas, and drone was like becoming a new thing at the time. Nevada was one of the FAA's drone test site, and we were actually in college at the time. My co-founder was developing drones to detect radiation. And then. But it was very difficult. It was very difficult because drones is like very hard. It's embedded systems. There's like mechanical systems engineering, and then also just software side of things, just to make the drones fly, but also interact with other sensors to like sensors, and then for the drone to autonomous fly and detect the radiation.
Your dog is just going crazy, Jinger. We can hear the dog in the background, but that's what happens when everybody works from home, right? There's nothing you can do about it.
Right.
But it's fine. So
right at time, right? So okay, let me keep talking. So what happened was that then we end up actually created a startup to develop drones to develop drones. And at the time we had to make our own flight controller, and so what we did is we went online and see if there's like open source projects that we could leverage, and then found out about PX4. So with that, we actually got to a product really fast. And let me just show my screen here also.
I'm sorry, Ginger. Your dogs are making me laugh a lot. This is So, are you sharing your screen right now?
Yeah, let me do this really.
Okay.
Are you able to see my screen?
There we go.
Okay.
Yeah, we're adding it to the stream right now.
At the time, what we did is a bunch of developer kits, right? Just because we really feel like others are very difficult in producing drones from the hardware and software side. And then, so this was actually a board that we created. By the way, all drones basically it's based on ARM. That is called Lucy, and used PX4. So that's how I originally got into the community and start working, and then found this like just open and collaborative environment, and that also we can collaborate with developers from other side of the world in drone development.
So I think it's really interesting. So you were telling me earlier this story. You started off developing your own drone, right? And you realized the kind of complexity in building a drone and developing all the software from scratch, the hardware, and you kind of got closer to what I think was founded back then, right? So PX4 was founded. I forgot exactly the year, but probably around the time you were building your own drone, right? So it kind of came about that you found out about PX4 and you started using PX4 in your project, right? And in your drone. And so it's interesting that now you are actually the community manager for Dronecode, right? And you're kind of sharing the usefulness of this not just the PX4 reference architecture, but also the software stack, the drone software stack, with all these developers out there. So perhaps, Gonzalo, do you want to say a few words on how you found out about PX4? Ramon is saying, actually, we've got here, before, I was just going to say, Ramon is saying that it was founded 12 years ago. So I'm not sure when, Ginger, when you built your first drone, but.
Yeah, we can get to PX4's history, after John, go with his experience.
So Gon, if you want to share how you found out about PX4, that'd be great.
Yeah, of course. Yeah, I got into PX4 like I've mentioned. I had a friend of mine that already worked with Jinger in PX4 because he did like a master thesis using drones, and then I got to talk with him because he worked with me at the army at the time. And he just talked a lot about drones, and I said, okay, I have to try this. And I tried some of the simple stuff, and then he introduced me like, but you can try this too, and that too, and introduced me to Jinger, and Jinger talked to me and said, you gotta try this and that, and I just started trying things and liked it. So I think it's very easy to everyone to get started. It's pretty straightforward. You have like a lot of documentation, so don't be afraid. Every pro was once a noob. So,
and so, I guess sorry, Robert.
Oh no, I mean I have a question, but please go ahead.
No, I was just going to ask you, and then I was just going to ask you, I guess, from your experience, right, when you started using PX4, how. What was the problem that you were having as a developer, and what did PX4 solve?
I didn't have a problem because I was not included in any project. Okay. So I was working at the army, not regarding drones.
Okay, I see.
So I just tried as a hobby, and I just started working and contributing as a hobby, not regarding any projects or any company. Just contributing to the PX4 ecosystem and trying things and validating things. And so I can't say that I had any problem regarding and I had a drone and I solved that problem using that drone in PX4. I can tell you that. But I liked it, and I can see all the advantages you have, like of using drones with PX4 to solve a lot of problems. You can see like companies using like storage units, and you can do like all the things being registered using a drone, or you can have like reconnaissance of areas and buildings and stuff like that. You can do a lot of things with drones, and I never did it regarding any project, but I've seen a lot of things being done by people like me and with more experience than me, and I see that it can be very useful, and not be afraid to try it. It's not that difficult to get into the PX4 ecosystem. It can be medium difficult to do complex stuff regarding machine learning and something like that, but the simple stuff you can do it, and you can plan missions in 5 minutes and upload it to the drone and just survey the areas.
Cool.
So real quick, if I may, while we're on the topic of PX4 and contributions and all this kind of stuff, I mean, I think it's awesome, right? So you're talking about this repository, or I should say org, with all these repositories. And I was digging through the firmware repo, right? I think this is the one where you host your releases. And so, I noticed 10,000 plus forks on this thing. Okay. There's like 30,000 plus commits. You have 200 plus pull requests waiting in there. And not only that, there's 500 or some odd issues that are open and being tracked, right? So this is a very vibrant, and it seems very active community. So I think that's excuse me, definitely something that should be pointed out. However, I'm still kind of curious now at this point, with all of this stuff that's happening on this repository, and I'm guessing this is just one repo in this whole org. How is this maintained? I mean, who's maintaining this? Who's vetting all this stuff? You said that you do some validation, right? But I mean, who is doing all this validation? Who's testing all this stuff, merging all these pull requests? Because it seems that you all have your work cut out for you on this repo.
Yeah, I think that Jinger would be better to answer this one. Jinger has got more knowledge regarding all the maintainers of the repos.
And I'm also curious about the process too, right? So like, what's the maintenance process? So maybe you could cover that too.
Yeah, absolutely. That's a great question. So that's what makes it really unique, as a open source drone project, right? Rather than just like a pure software-based project, because the code not only have to run, it also have to run a hardware, and a hardware that flies, and that a hardware that if it falls down from the sky, that's huge liability. So some amazing stats, or like just things I can actually show is how many different PX4 based drones there are. So if you go to PX4's website, these are all the different commercial systems, all the different drones that runs PX4. So you can see things from that's multicopter, that's fixed wing, or also we have VTOL, which is vertical takeoff and landing type of drone, and as well as things that's probably out of your common thing of what you think as a drone. So if you look at the one on the right, the one that looks like an eyeball, that's a blimp, and that blimp has motors, and it also runs PX4. So for the kernel, and we like to call PX4 really like the Linux kernel equivalent in drones, to maintain that, and have a community that also constantly developing it, contributing it. It's a huge process, and that's actually part of why we have a maintenance team. It went from originally like the original development team, and then outgrow into a big maintenance team. We have overall probably about 10 to 20 different maintainers to maintain different parts of PX4. So Gon, the person that Gon that introduced Gone, to the ecosystem. His name is Nuno. Is one of our maintainer. And he would maintain like the ROS, which is and the middleware part of like PX4. And then there are also other maintainers who handles like the real-time operating system, which is Linux, that part of like the code. And then for the different vehicles, different maintainers, all have their all do their own. They're like the expert in that section of the code, whether it's like multicopter or like fixed wing, or for underwater. We also run like underwater vehicles and rovers.
Yeah. So real. Oh, sorry. Keep going. Sorry about that.
Okay. Was that me? Was that okay? The So the maintenance team actually also all work together. They do collaborate, and then we have a weekly dev call. We have weekly dev call where all the maintainers actually get to participate, online, and then solve issues and collaborate. And also Dronecode comes in. We actually organize the not only just software testing, but also hardware testing. We used to, before the whole pandemic thing happened, we had a testing that's based in Mexico that flies all different type of PX4 vehicles daily. And then, they would test out the different PRs, different pull requests, and that's part of the code reliability, whole infrastructure, so that we're making sure that the code runs well on different hardware. So yeah, I hope that kind of explains the process.
That's awesome. Thank you, Jinger. A question from me, actually. So, we talked about drone stack, right? The drone stack in general as a concept. Can you tell us more about what a drone stack is and what kind of parts it has, right? Like what are the different parts of the drone stack? What do you need to think about as a developer? I'm conscious that a lot of the people on this call or in this looking at this live stream are actually not very, they might not be experts in drones, but they might have a lot of knowledge around software development or embedded development, right? So, I think, the way I see drones is kind of a combination of many different things, right? So I wanted to hear from you, what are the different layers of the stack?
Yeah, so again, like it can be like really complicated, but the way I kind of from a just intro kind of like characterization, hardware, we separate into like hardware and software. It's basically a flying robot. And then so if you look at the hardware side, there's a drone frame itself, and then there's the power system, and then usually there's a payload, because ultimately the drone is just a data transferring or data detection type of robot. So payload side, usually there's either a camera or some sort of sensor. And then from the software side, actually, let me also just maybe pull up another illustration that might be helpful.
Okay, let me pull it up.
So I'm actually going to use one of our member company, one of Droncode's member companies' reference photo, right? This is a developer drone, and it's from this company called Model AI. They make these autonomous drone that's very awesome. And this is a pretty like it's a reference drone development kit. So has a flight controller in it. That's the center. That's the brain of the drone. And then that runs PX4, the firmware. And then usually there's a ground control system that's your ground UI, and then that talks to the drone. So in between, so also in part of like the software layer, there's a protocol. And and usually in the drone world is it's a standard that's in mapping. And then, of course, for people who want to build more software to control the drone, they can use MAVSDK or MAVROS to basically interface with PX4. Yeah. And
Jinger,
so that, yeah.
I'll pause you for a second there, because what's interesting, so there is a chat, so there is, people are asking questions in the chat, and there was this question that came from David W. So he's saying, seems like a lot of the functionality would translate to ground-based vehicles. Has there been any activity in this area? So I know Ramon has already answered in the chat as well, but I wanted to give you a chance to say something about this. And also, you just mentioned that there is a protocol, it's also shown here, MAVROS, right? So I know that that's a communication protocol to talk to ROS, so ROS-enabled drones, right? Sorry, not drones, robots, rovers, I guess, robots. So I was curious, if you can elaborate a bit more on this side.
Yeah, absolutely. Like mainly developers use ROS to do offboard control, and then it's on the intelligence and navigation side of like either computer vision based navigation. All the autonomous side is done with MAVROS.
It also, if I may add real quick here, I mean, I wanted to mention this. We haven't really gone through the PX4 website, but kudos to whoever built this, because it's amazing. I want to share my screen real quick, if you don't mind, on this note, because if you go to the PX4 website, it's just so straightforward. You can go check out the source code. You can go check out the documentation. You can literally click to access the latest release. And this is where I was looking at just recently. If you scroll down to the previous, I mean, the most recent release is up here with all these highlights. But if you scroll down to the previous release, you'll see, what people are kind of using this for. You see the rovers, the underwater vehicles, as she mentioned, virtual takeoff, drones, simulation, all sorts of information there on these releases. But back to I don't even know how to go back without getting rid of this. But back to the to the website here, Jinger, when you were going over the commercial systems, I mean, there's also a nice little area to go check out compatible hardware and an area to go check out community projects. So if you go to the PX4 website, very easy to remember, px4.io, you can go explore all of this stuff there, and it's pretty easily accessible. Yeah, no, whoever built this, if you're listening, good job on building this website. I love it. It's simple and easy to use, so very nice.
Well, me and Gon here built it, so thank you.
Oh, nice, yeah.
Yeah, and actually,
oh, wow.
That's one thing I want to talk about. The if you go to the community projects, actually, Robert, like if you come back,
I'll bring it back. I'll bring it back.
Yeah, the community projects. Or actually go to the community on the top top bar and go to projects. It will take you to the Hacksters community hub. So one thing is that people sometimes, when they hear drones, they don't have ideas or they don't know what they can develop drones with. But actually on Hackster, we have just series of different community projects where people build different projects. That's just really awesome. So if anyone wants to get started, if they need inspiration, that's somewhere they can check out. There's a lot of really awesome tutorials in there.
Yeah, we can add the banner here too. So, awesome. Just in case, we'll make sure. Oh, that's the PX4 one. Did that one not add? Here we go. Oh, that's where it is. Hackster.io/PX4.
And I just wanted to bring up actually a comment from Ramon here. Hi, Ramon. He confirms that we've got the people that built the site on this call. So there's a confirmation from someone else externally to you, because how can we trust you, right? But someone else is saying it, so it must be true, right? So no, it's really good website. I had been on it before, and yeah, no, kudos to you guys.
Yeah, I didn't know that, but I didn't know that, by the way.
Go through the,
Yeah, it almost sounds.
Then let's show actually another part, right? So how you could also get started with PX4. We if you go to software, go to like getting started. Yeah. So usually there's either people come in either from the hardware side or they from the software side. But what we would really want to show today, maybe it's just for people who can't get access to hardware, because of pandemic stuck at home, they can actually also play with a simulator. So which is a fake drone so on the right hand side, if you do the try hello sky, it will take you to steps on
very clever, by the way. I like that. Hello sky instead of hello world.
Yeah, it will basically take you to set up the PX4 development environment.
Okay.
And then you'll have the PX4, the kernel like running on your on your machine, and then you can and basically have they set up a simulator to get you really start developing drones in simulation. And I think that we can actually get on to do a live demo here.
That's awesome. This is very straightforward too. Just download, install, launch, take off, and analyze. So who wouldn't want to try this? Hello Sky. Very cool.
Jinger, correct me if I'm wrong, but is it it's using the same backend simulator that the ROS community is also using, right? The open source ROS community, Gazebo, right?
Yeah. So there are actually a couple of simulators that works with PX4.
Okay.
There's also one from Microsoft called AirSim. So AirSim also works with PX4, but one of the most used in our community is Gazebo.
Awesome, cool. I always like when different communities, come together and share knowledge and share expertise, right? So that's really cool to see. And I love the fact that there is a really good communication or good connection between these two communities. So that's really nice to see. Do we want to have gone actually? So I know there's something coming because we've got a real demo here, right? So is it the time for the demo yet?
I like that idea.
Yeah, I mean, while we are on this topic, right? Like simulator, we can just have gone to the live demo really quickly, and then after that we can talk more.
Yeah, and I want to remind everyone, we did clear this with Gon. So if you have questions while he is demoing, he will take questions while he's demoing. So feel free to post them in the chat, and we'll bring them to him ASAP. Gon, the floor is yours.
Yeah, let's do it. Let's share my screen. Okay.
I think we've got a comment from you for you, Gon. Is that for you?
Yeah. Yes, it's
that's why I brought it up. I was assuming it was.
That was my mentor, Nuno, the guy
awesome.
who showed me PX4.
Awesome.
By the way. So I will try to give it. He's telling me to give it.
So if you bring up the
yeah, I think I did. Are everyone
so I'll bring
seeing
it up as soon as you change
screen?
the screen because I can see the other. Yeah. There you
go.
Oh,
okay. Okay. So here I go. First thing first, you can do one of the things to start the PX4 code and with the simulator. One thing you can do is go to px4.io and you can just go to the documentation. And if you want to build it in your machine, you should go to the PX4 developer guides and go to the getting started initial setup. And then you go to, after read the initial setup, you can go to the toolchain installation. Right now I'm using Linux, Ubuntu 2004, this version, the LTS one. And you just go to here and you clone the repo and just run this script, and this is going to install all the dependency and all the simulators you need to build the PX4 code. But if you think this is too difficult to do, or you can't do it, you can always use a Docker image produced by Jonas Vodern, one of the MAVSDK maintainers. He produced a Docker image that already has all the environment installed and the Ubuntu and all the dependencies, and you just have to run it. It automatically builds the code and launches Gazebo headless. Headless means without GUI, okay? So you don't have the simulator image, which the simulation is running on the background. So I will try it here very fast for you, just show it how easy it is. You just pass the command. This is going to build. I already have the Docker image downloaded and running, so it's faster, but this is pretty fast either way. So this is running. The drone, the simulation is running, and now you can give commands using the PX4 console, okay? So I'm just going to give one. It's commander takeoff. And the drone is armed and is taking off, and I do commander land, and the drone is going to land. You are not seeing anything because we are running Gazebo headless, but right now I'm going to show you how to build it locally. You will build it locally using cloning the repo. You just go to the PX4 documentation, and here to install the toolchain, you clone the repo, or you can just clone it and then install the toolchain. And to run the code, you just do this, okay? You just do PX4, you just do make PX4 CIRL. CIRL means software in the loop, because we are using a simulation. So we are using a simulator environment to get information to the drone and to the sensors and to command the drone. So next, we will specify the simulator. We can use Gazebo, or you can use JMAVSim. I will launch with JMAVSim, for example. That is another simulator. And this is starting the simulation. And cool, right? We have a drone in a nice green field. Pretty awesome, right? So let's try and take off. It's always good practice to try and take off the drone in the PX4 shell before doing anything else. So let's try it. It's armed and takeoff is detected, and it's taking off. Nice, right? We have taken off a drone, so we're just going to land it.
Just a quick question.
Yeah.
Just curiosity. So when you do take off, does it keep on going up and forever, or does it have a limit of how high it goes up?
You can specify it. I will show you in a moment. I think from here the console, it will just take off until a default altitude.
Okay.
But you can specify it when you are using MAVLink and MAVSDK and QGround control. I will show it right away. It's more straightforward to show you in the next things, in the next
Sure. Yeah.
technologies we are using. Okay. So, yeah.
Gone. How easy is it, or difficult is it, to go in there and accidentally screw something up, right? Like, I mean, how easy would it be to go in there and when you say take off, one of the propellers throws it over to the side? I mean, how easy would it be to mess that up?
You have like a lot of safety measures implemented in PX4 firmware. You can specify it before flight. When you are using a real drone using QGround control, you can specify like emergency things to do. You can have a parachute, or you can land it immediately. But the drone can fly with 3 propellers, so it cannot fly as good as with the 4, but it can fly with 3 and land with 3 safely. Yeah.
And the cool thing about simulator is that in the early beginning period, you don't get to break so many prompts, like road prompts.
Yeah, and I mean, the other cool thing is that, while we're all at home, anybody could try this for free, right? Like, I mean, this is all open source. This is all available, as you just showed. So everybody could go off and try to fly a drone effectively like almost like if you were flying a real drone before actually buying one, right? So that's quite cool, actually.
Yeah, and you can simulate in Gazebo. You can make worlds, and you can simulate structures like you want, and crash drones and stuff like that. You can add stuff to the drone, gimbals or weights or stuff like that, and just try and crash it and try the safety measures if they are running or implemented. You can try a lot of stuff in simulation. It's always advised to try it all in simulation before trying it for real. Okay. So just go ahead. You can do it as fast as I've done it. So you can just go and start the Docker image and you are running a simulation, or just install the toolchain. You have a GUI simulation. But if you are running the Docker image, you are thinking, oh, but I'm not seeing anything. Okay, but you can see it using the Docker image using a QGround control that is a ground station. Okay, it uses the MAVLink protocol Jinger talked about to communicate with the drone. And here, as soon as you open QGround control, you can see the drone and geographically where it is. Okay, and you can give commands to the drone using QGround control. You can like take off, and you can specify the height here, like I told you about before. You can specify. You can say like 2 meters, and you can say, okay, but I want to hold. Okay, so I will take off, and the drone will take off and will hold position.
That's super awesome. So is this two different tools coming together into one tool, basically, right?
Yeah,
because
yeah,
you've got
Yes, it is. And you can use QGround control on your mobile phone or on your PC, because when you are working with the real drone, it's easier for me to use my phone. And I have QGround control, and I'm always seeing things and reports in real time with telemetry. And it's QGround control is awesome. You can do a lot of stuff with QGround control.
I think sorry, I was going to say, I think my companion robot that we were talking about a couple weeks ago is going to be a little mini drone that sits on my shoulder. And then I can send it off to do things and then come back and see Alex Glow compete with that.
you gotta be careful for your ears, though.
Yeah. Oh, that's true. Yeah.
Yeah, it's gonna be difficult to compete with that. Yeah, it's gonna. Yeah, because this is already working. No,
Cool.
this is. Yeah.
I just wanted to take a couple of questions from the audience, actually. Should we do that now? Yeah, I think let's take a couple and then we can keep on digging into the demo. But so the first one is from David W. So he's asking, what does the obstacle avoidance sensor stack look like? Computer vision, LiDAR, simple ultrasonic. So either of you want to take that? Yeah.
I don't know if I can answer it like all the way, because I'm not that experienced with computer vision or machine learning. I've learned some things, but I'm not that experienced. But one thing I can tell you about is, if you want to do some hard computing stuff with CPU or GPU intensive tasks, you can always have like a companion computer in the drone, like a Raspberry Pi 4 or something like that. And then you do the computations. You can use like MAVSDK to communicate with the drone using MAVLink, and then you can get all the information from all the sensors, camera, and all the others you want, and then you can do the hard computation in the Raspberry Pi, and then send the actions back to the drone and make drone act accordingly to the things you are planning to do. Yeah, I don't know if I answered the question.
Yeah, I think that makes sense. Is there, is there the concept of obstacle avoidance in the drone stack? So in PX4 itself, is there functions that help you with that, or is it something you have to build on your own?
So if you go to PX4's repo, there is a repo called avoidance. So I think like either Robert can bring it up, or I can bring it up. But yeah, in the it's the avoidance stack that PX4 have already built, and also have great documentation. But to answer David's to answer like David's question, it's a combination of it's a combination, of all. There's the computer vision based. There are drones. That's also like lidar based. There are actually a lot of like different applications. But yeah, check out this repo. It's pretty awesome.
Cool. Awesome. We've got another question as well, so I'll ask that as well right away. So does it detect the failure of an engine via current usage, etc., or is it manually done via ground control? Hyatt is asking.
It's automatically, it detects, the firmware detects the failure. Probably you need to configure the by default it has like some behavior, but you can configure it like fail safe stuff, like I told you about, like parachute and stuff like that. You can configure it like lands right away, or configure it to do some kinds of operations. Here in Q ground control, you can just go to safety. You can check a lot of stuff like collision prevention, fail safe action, action on breach, climb to altitude of return to launch, then landing descent rate, stuff like that. You can configure it. Like battery warnings and stuff like that. And you can always configure a lot of stuff here.
Yeah, absolutely. And also there's in the documentation, there's also a failure detection. So all the things that shows up on the QGC is also documented in the user guide. And we have, I think, over 20 different failure detection modes.
Awesome. Yeah. Cool. Right. So do we want to continue on the demo? We've got about 10 minutes left. So it's up to you, Gon, if you've got something else you wanted to show.
I can show you another thing very fast. I will not show you how to do a mission here in Q ground control, but you can just go here and plan a mission, upload it to the drone, and tell the drone to continue the mission. Okay. Awesome. So I'll not do it because this will take a lot of time to complete the mission. So I will skip to another thing. I will show you how to use MAVSDK. That is a C++ library. I will not get in details, but this C++ library builds into code to other languages like Python, Go, Java, JavaScript, C#, and stuff like that automatically. So it has language bindings. It uses gRPC to do the mimicking of the functions. It uses proto files. Okay, so I will show you very fast how to use like MAVSDK to write a Python script and command a drone. This is very fast, so I will just show you. I will start very quickly here a Python virtual environment. I always like to do this. Okay, I will just start it now. Okay, it started. So if I want to use MAVSDK to command a drone, give commands to a drone, I will try to use MAVSDK Python. And for that, you need to install AO console, because you need an asynchronous REPL terminal, because MAVSDK utilizes asynchronous calls, because you need to await for the drone response, right? You cannot just send an action to a drone and not await this response. You don't know if it worked or not. Okay, so you need to install first MAVSDK, and okay, it is installed. Now you need to install AO console. Okay. Okay, it's already installed. And now, instead of doing Python, I will do a Python to start this asynchronous console REPL terminal. And then let's try and do stuff with MAVSDK. I will import MAVSDK, and then I will need to start a MAVSDK server. I will not get into details about it, but you can read all about it in the documentation. This is how you start a MAVSDK server, because this is like an intermediary system to talk with MAVSDK C++ library. After doing that, you need to await for the drone to connect. You do drone.connect, okay? And the drone is connected. You can see it here, that drone has a partner IP. And next, let's try and do await. The drone is flying, so we need to do await drone action dot land. And it's landing, okay? Very cool, right? We are writing Python and giving commands to a drone. This is very awesome. And we can take off again if we want, okay?
So, Gon, I have a question here. I mean, I'm watching all this stuff happen on your native machine, your local machine there.
Yeah.
We didn't really touch on hardware requirements. I mean, you're running this simulator. Is it really system heavy, or can it just run on pretty much anything? Like, what's the spec of your machine that you're running this on, or is it just really lightweight?
Yeah, my machine is like 6 years old and is a laptop.
Okay. So it run on anything.
Yeah, I have a dedicated GPU, but it's a old one, so it runs on anything. And I have another laptop, and I tried it, and it runs. So cool. I don't know what are the minimum specs for this. I don't know if Jinger knows what are the minimum specs for this, but I can tell you it's not a lot.
Yeah, I mean, I also saw on the website that you pretty much have it covered across from Mac, Windows, Linux, pretty much on anything.
Yeah.
So that's cool. Thanks.
There are some stuff that don't work on all the OSs. If you want all the things to work, you need to go on Ubuntu 18.04 or 20.04. Okay.
Gotcha.
Okay.
Cool. So I've got one question for Jinger. So we talked a lot about software here, right? And all this amazing software that you guys have built over the years. It's really cool to see, all these things come together. And when I think of a drone, I think of a complex system, right? And it's really cool to know that all this stuff is available out there for people to build on and to use, right? Now, I'm curious though, a drone for me is, there's a lot of software, obviously, but then there's hardware, right? And I know that you guys have worked quite a lot on standards, right? So standard hardware for drones. So I want to give you a chance, Jinger, to kind of talk a bit more about the hardware side for a couple of minutes, perhaps, given that, I think that's an interesting topic for our audience as well. Jinger, can you hear us?
She might be on a delay.
Okay, we might.
Yeah, we might want to. She might be on a bit of delay. Also, we have to keep in mind there's 2-minute warning, everyone. We'll be closing out soon. But Jinger, can you hear us?
Yes, I can hear you, and
okay,
I am back. Sorry about the Chinese internet thing. But
no
thanks for bringing that up, Alessandro. Like, we work a lot in what we call open standards for drone hardware. And so what these are basically, like specs and reference designs for drone hardware that just, runs with PX4. Part of what we have, in terms of standards, you can go to pixhawk.org. Go to pixhawk.org, and you'll be able to see the standards, what we call for like autopilot. So manufacturers, they can go to these reference standards and basically and build a flight controller, and that's actually how PX4 Pixhawk all got started and got adopted so fast. And we also are working on the hardware side, like payload bus standard and also battery standard. So that really covers a lot of just like the core components of things that interact with the firmware, right? And then of course these are the products. These are the products that's built, from the community throughout the years, when these standards have actually been around for a long time, and just all these different hardwares.
Awesome. And what's really interesting is that so I've seen a lot of development recently with multiple mission computers or companion computers, right? So I think it's fair to say that most of these flight controllers are based on ARM microcontrollers, as you mentioned. And what's interesting is that now there is this new trend of having these more low power mission computers, right? That are kind of quite capable. I mean, we all know the Raspberry Pi, for example, is becoming more and more capable by the day, right? So I think a few years ago it was it was this little computer that you could use to do certain things. Now it's basically a computer, right? And so it's super cool that I think I've started to see drones with Raspberry Pis on it, right? And it's quite cool as a kind of first step, right? To combining basically the ARM CPUs that run Linux and the ARM microcontrollers into one drone.
So, Alessandro, I want to be conscious of the time. We're at 1 minute over. I think we should at least give each of them 1 minute of shameless plugs. And also, I want to remind, I'm not sure who put this in our document, Jinger or Gon, you had a mention here. You wanted to talk about 2 events that were coming up. One that's from the Linux Foundation and then the RosCon. Did you want to mention those real quick?
Yeah, absolutely. So
okay.
If you're interested, so for any of the audience, if you are interested in getting to know more about PX4, about how to develop drones, with all these open source tools, you can find us at 2 events that's coming up. One is
screenshot that real quick. Oh, you're gonna put them up there.
Yeah. So one is the open source. One is the Open Source Summit Embedded Linux Conference at October 26th, 29th. But we actually have an open source drone mini summit. So if you go to their website, we'll post a link here later. There's an open source drones minute hosted by Dronecode Foundation. And then in November, we have the ROS World. We're at ROS World. So if you go to RosCon anyways, this year is a free show, virtual, and there's like 6 parallel tracks from different open source communities, and we are one of them. There's also, great content on MapRos if you want to get more content about, the simulation and how to interact, with ROS. We have great content there. So that's my shameless plug.
And I'll do a shameless plug for a contest that I think is super cool in relation to drones. So if you've got if you're trying to, or if you're interested in looking at getting involved in this in the drone space, and you want to participate in a contest, there is a really cool contest on Hackster actually. It's a contest sponsored by NXP. And it's called NXP HoverGames Challenge #2, because there's been #1 already finished, and then there's I'm hoping there's going to be more, because it sounds like it's one of a series, right? So it's really cool. So I think there is 39 days left to submit your ideas.
These Hackster contests are really cool too, by the way. I mean, if you haven't participated in one, I mean, we've hosted some before. I think Alessandro, you did some last year or 2 years ago through ARM. And I mean, 96 boards, when I was 96 boards, we kind of participated in that. But I've made some amazing friends. I mean, some of the people who are in this call right now, like iShot JR and David W., we've made some amazing friends through these Hackster contests, and you get to really network with really smart people around the world. So I definitely encourage you all to check out this contest on Hackster. It's cool.
Yeah, cool. So, Gon, it's your turn to do a shameless plug.
Yeah, I don't know if I have one. I am talking at the OSCS Web Summit, the open source Web Summit. I have a talk there. So if you want to know a bit more of MAVSDK, you can check me there. Yeah. And if you want to learn about ROS, I have a couple of friends of mine that are doing talks at the ROS World. So
can't wait till these
check
events come
them
back
too.
to in person. I mean, I remember at what is it, TechCon, we had the big NXP netted area where they were flying drones around and stuff. We need that again. Bring that back.
Yeah.
Yeah.
I want to see live drones flying around.
Yeah.
Yeah. I remember we
Yeah.
we had a fun.
Yeah.
We had one of our TechCons, actually, one of the last conferences. We had the big eye in the sky. Actually, that was cool as well. But this, I thank you so much, guys, for joining us, and thank you, Jinger. I'm really, I'm aware that it's really late for you, and so thank you double for joining up. Sorry, it was really cool to have you. Always a pleasure to chat and to hear all the great stuff that the community is doing. So, and Gon, it was nice to meet you and hear the work you're doing, and thank you again both for joining.
Yeah, and on my part, as always, I like to thank you as well. Alessandro pretty much summed it up. You guys are awesome. Thank you so much for joining. Jinger, I hope you get a nice rest. And Gon, awesome demo. There was nothing. The demo gods were on our side this time.
Yeah.
Nothing
For
went
sure,
wrong.
for
So
sure.
congratulations. As always, also, thank you all the viewers. Thank you everyone in the chat, everyone who contributed and asked questions. Ramon and Nuno who joined us also to show some support. So much appreciated. Hope everyone has a wonderful rest of your week and a great weekend. Drones.
Thank you
Open
so
source
much.
drones.
Bye. Open source
Vegas.
drones.
PX4.
Take care. PX4. Cheers.
Yeah. Bye.